Hi guys, in this video I'm going to run through some of the most common errors I have come across when it comes to fractions in the Year 6 SATs.
Here we have a simple fraction addition, and the most common error we see with this type of question is not recognising that the denominators are not the same. So we could either have them just adding the numerators and adding the denominators together, or keeping one of those denominators in the answer, so 8/4 or 8/6. This is very, very common. Again, with a subtraction question, another common error is to not recognise that the denominators are the same. But I'm going to add another element here. What can often happen is we subtract the numerator, which leaves 0, which might confuse some children, and they might start doing some other things to compensate for that. And then the 3 subtract 5, often they won't put a negative number. Often what will happen is the 5 and the 3 will be switched around, and this would become a 2. So this is another common error that I have seen when marking SATs. With multiplication questions, I often see these either being completely left if a pupil just really doesn't know what to do, or if they are actually quite good at adding and subtracting fractions, what often happens is they apply the same reasoning to multiplying. So they'll look at the fact that the denominators are different and actually try and make them the same, which is the correct method for adding. So we might find that they do something like this, that they change each fraction to find the equivalent fraction. So 3/8 would be 27/72, and 6/9 would be 48/72, and then they might subtract these, and so you might have some very long-winded calculations. You might have some calculations on the page like this, where they're doing long multiplications and just going to end up with the wrong answer. We may be left with a very long answer here with a very high value for the numerator or denominator, or we may see these workings and then it just be left blank because the child has given up. I will go over what the correct method is in the next video. For fraction division questions, what we often see is the multiplication method being applied. Now, the division method, the correct method for dividing fractions, does have an element of the multiplying fractions in it. However, there is a step beforehand, and it's really common that that step gets forgotten and that children just divide the top, so 6 divided by 2 and 8 divided by 4, especially if the fractions are like this and it's easy to divide the top and easy to divide the bottom. So this is a super common misconception. Please watch part 2 of the video series where I explain exactly how you should be solving this question, because this is actually the wrong answer. For a question with adding mixed numbers, children are often taught to partition the whole number, the integer, from the fraction and to add the separate parts. Now, this can work and it can often work. However, it does lead to some very common errors. I always recommend converting your mixed number to an improper fraction, then adding that first. I will go over more of that in the next question, the subtraction one. I'm just going to show you what often occurs. So we often get children partitioning our whole number from the fraction and then doing each bit separately. So 1 plus 1, and then 3/6 plus 5/9. Okay, so I'm going to rush through without explaining too much of the methods for each part. I'm just going to show you why this sometimes leads to common errors. So we've got our 1 plus 1, which is 2, and then our 3/6 plus 5/9, assuming that the child knows how to change these to equivalent fractions. Your 3/6 is going to be 9/18, and your 5/9 is going to be 10/18. So we can now add that. So we've got 19/18. We now have our correct answers for the partitioned parts of the mixed number. So we've added our whole number, our integers, we've added our fractions. We now need to combine them back together. What is commonly seen is children to write in the whole number and then to write in the fraction, which is incorrect, because you cannot have a whole number and an improper fraction. You need to either have it as an improper fraction, or a mixed number means you've got a whole number plus a proper fraction. This is not a proper fraction because the numerator is larger than the denominator, but this is super common. It's super commonly seen, super frequently seen as an answer which would get 0 marks, even though the actual maths is correct. The final answer is not. So here I'm going to show you mixed numbers again, but when it's a subtraction. And here again we're going to use the partitioning method, which can work for addition if you carry all of the different parts out, but with subtraction there's more of a chance that it won't work even if you feel like you have carried everything out. So 2 subtract 1 is 1, and then we would do the 1/5 subtract 1/2. So we obviously need to find a common multiple so that we have the same denominator. So if your child is secure with subtracting fractions, they may change this to 2/10 subtract 5/10, which is all correct. 2/10 is 1/5, 5/10 is 1/2. And the problem here is we've got a smaller value subtracting a larger value. Often what we see here is the brain compensating here, and rather than doing 2 subtract 5 and realising we actually can't do that, we often see children will switch it around and then do 5 subtract 2, especially when it's a long-winded calculation and there's multiple steps. It's very, very common to just get to the last part and just make it work. So they might add 3/10, and then they might then remember, well, I need to combine my fraction and my number and write that as 1 and 3/10, when in fact this is not the correct answer. I will go through how to solve the correct, how to find the correct answer using a correct method in part 2 of this video. With questions like this, where we need to find fraction, decimal and percentage equivalents, if a child doesn't know how to do this, we often just see a bit of guesswork, looking at numerators and denominators and comparing the wrong parts. So often we might see something like they're looking at the denominators, they may put 1/2 in first. I'm writing the values in rather than the letters so that you can see the thought process that I'm describing. We may then see the 0.05 because they are seeing a single digit number, and then they may think, okay, well, there's 1/5, now there's 2/5, and then simply add, compare these by the double digit number, the 39 hundredths and the 42%. Some of these comparisons or some of these values are ordered correctly compared to its neighbour just by almost guesswork. So if your child doesn't know the correct way to compare fraction and decimal equivalents, what we simply get is a guess. I will show you the correct method in part 2. I will show you the correct method for this in part 3 of this video series. What fraction of this whole shape is shaded? This is a very common question that can throw children, partly because the shape isn't sectioned into equal parts for them. So what we often see is they'll count how many parts are shaded and they'll see 3, and then they'll count how many parts there are altogether, 1, 2, 3, 4, 5, 6, 7, 8, and they will just simply write how many parts are shaded out of how many sections are there that are visible to them. This is not the right answer, and I will go through how to answer this correctly in part 3 of this video series. Seats for a show are sold at 3 different prices. We've got 30% of the tickets as price A and 1/5 of the tickets are price B. So we've got a percentage and a fraction, and the rest of the tickets are price C, and we need to find the percentage of those tickets at price C. So this is going to involve us figuring out what all the tickets add up to in terms of a percentage or a fraction, and then finding out what is left after we've subtracted 30% and we've subtracted 1/5. When children are not very secure with the fraction and percentage equivalents, that's when these kind of questions can be very tricky. And what we might find is, because the answer is in percentage and the first part of the question is in percentage, we might find that they deduct the 30% and realise that these two add to 70%. But then what often happens is they either find 4/5, which is the remaining, the supplement to 1/5. They might find 4/5 of 70% and write that as the answer, or they might find 1/5 of 70% and then take that away to find the answer. So 1/5 is 14, so if I just write that in brackets, so they might find 1/5 of 70%, which is 14, and then find what needs to be added to that, which is 56. Or they might find 4/5 of 70%, which is 56, and then they might add that in for their final answer. So you'll often see something like that, or you may just see it left. Some children just don't even know where to start with it when you have a combination of fractions, decimals and percentages in a question. But this is a very common type of question that appears, and I'll go over how to answer this in part 3 of this video series. The final example of our fraction skill questions is one that is mixed with some measurements. This is very, very common as well. We've got different units of measurement here, and we've also got fractions. So there are a few different skills that are going to come into play in this final question example. There are a few ways that this question There are a few common errors for this type of question. I'll go through a few of them, but because there are multiple steps, it's really, really common that some of these steps will get missed out, or some steps are completed and they're not added together in the right way, or the final answer isn't plucked out from all the working out that's done. So we first of all have 250 grams of grape, so we have to figure out that what fraction of a kilogram the grams is. So the first common error is that children don't know how many grams are in a kilogram. So they don't know that 250 grams is a quarter. Okay, so that's the first error that might happen if you're not au fait with the measurements. So let's just assume that we have figured that out right. So it's a quarter of the kilograms, and that is 75 pence. You'll probably already see that 75 pence itself is something that could become an error, because we're now mixing up pounds and pence as well. Then we've got 1 3/4. So this tells us what fraction we need, and it's using the same unit as the price tag. So what can happen here often is that the 3/4 of the kilogram is found, which is the £1.20, and sometimes the 1 kilogram is forgotten to be added. So this 1 3/4 should actually be £2.80, because it's the £1.60 for the kilogram and the £1.20 for the 3/4 kilogram. So that is another common error. We might take the 3/4 and not the 1 3/4 and then add that together. So let's say you've got the right idea for quarter of a kilogram, and you have also got the right idea for 1 3/4. Then the adding up. So the adding up of your £2.80 and your 75p. This can be added up incorrectly if we don't write the 75p as a pound. So like that, if we're not adding up. Then another error is, even if we are adding this up, it could be, after all of that thinking, that we just forget to subtract it from 5, or that we subtract it from 5, and we often see things like this, where then the actual subtraction isn't carried out right. So what we want to see is £5.0 subtract £3.55, then to get the correct answer. But this is the final step that can sometimes trip us up here, is the actual subtraction with decimal numbers. So you may be thinking this is a subtraction problem, not a fraction decimal percentage problem, but it is actually a decimal number problem, which comes under the fraction part of the Year 6 curriculum. It is adding and subtracting with decimal numbers. So there are multiple things that can go wrong with a question like this, and this question does usually have at least 2 marks, maybe even 3 marks, to allow for those different common errors to appear. Don't forget, you can actually download all the questions in these videos for free, so your children can have a go for themselves to see where their strengths and weaknesses lie.